So this is the last topic within moments. This time, rather than looking at a laminar, we're looking at a system of particles which are all connected together by some rods. So basically what we're looking at is what's called a coplanar system of particles. And up here is a typical exam question. So we've got a diagram here showing three particles A, B and C, and they've got masses 7, 3 and 5 respectively. So remember this word respectively means A is 7, B is 3, C is 5. And they're attached to light rods, and this word light means that they've got no mass, so the rods themselves don't have any mass, and obviously rigidly joined together just means that it's not going to change position in any way. We're given the coordinates of those particles within the plane, and all we've got to do is find the coordinates of the centre of mass of the system. So we're doing it very similarly to what we've done with the laminar, but rather than having sort of areas or shapes, this time we've got particles. So we've got particles A, B and C that we've got involved. Instead of the area of the shape, this time we're dealing straight away with the mass. So we've got 7, 3 and 5 in that order. And rather than looking at their position relatively to normally the point A on the bottom left-hand side of the shape, this time we're basically going to be measuring from the origin. So we're going to look for its x-coordinate from the x sort of 0 point, and we're going to be having a look at the y-coordinate from the y0 line. So, as they're in coordinates already, that's really helpful. It's obviously possible that you might get a diagram where you'd have to interpret the coordinates yourself, but hopefully that should be something you're comfortable with. So A's got coordinates 4 and 0, B has 3, 7, and C has -5, 1. So again, exactly the same way as before, our total mass, we're not taking anything away from each other, we're adding all of it together. So total mass is 15. So remembering our formula from before, the total moment of the system is equal to the sum of the moments of the individual areas, or in this case the individual particles. So our total mass is 15, so 15 times by the x moment coordinate is going to be equal to 7 lots of 4 plus 3 lots of 3 plus 5 lots of -5. So adding all of that one up, we get -6 altogether, which when we divide it by 15 gives us -0.4. Okay, so there's the x coordinate. Now we're going to do exactly the same thing with the y. So 15 y bar is equal to 7 times 0 plus 3 times 7 plus 5 times 1, and rearranging that one is going to give us our y coordinate. So 7 times 0 is nothing, 3 7s plus 5 divided by 15, not such a nice number this time, 1.73 recurring, so that's going to give us 1.73 to 3 significant figures. So our final answer for the centre of mass, I think it would be nice to write this as a coordinate, so -0.4, 1.73. There we go. A second very similar question now, the only difference being that this time we've got 4 particles, I should say 4 there, 4 particles A, B, C and D of masses 10 kilograms, 6 kilograms, 2 kilograms and 5. So we're just following the same procedure again, fill that all in. If you want to take a quick pause on the video now, try and do it yourself and then come back and check at the end. Okay, so there's the table all complete. We're just going to get our total mass at the end, so 16, 18, 23 kilograms is the total, and now we're going to find our x bar and y bar. Again, I'm going to pause this now and then you can come back and check. Right, so there are the two calculations, so I'm going to again say centre of mass is 1.83, 1.26. And that's it for this final topic.